All right, welcome back. So here we're looking at a new topic, and that topic is going to be a binomial random variable. Now, the binomial random variable is one of those random variables that's very common. The whole point of this section is to describe the behavior of a variable of interest. And if we have that behavior, then we're going to be able to find a lot of things like the expected value, probabilities, um, or just have an idea of like likely outcomes and unlikely outcomes. Here, we're faced with a very common scenario. So remember, we have a large population. So we're going to go ahead and denote that with capital letter N. And we're interested in the uh, proportion of individuals, right? The fraction of individuals that have a certain trait or characteristic. So if I take a small group from this population, then in that small group, we can observe that this person has a trait or a characteristic that I'm looking for. So does this person, and so does this person. And this procedure of taking a sample and then observing whether there's a trait present, right? So in other words, where the person's going to say yes, or you're going to analyze this person and you're going to state, yes, they do in fact have the trait that I'm looking for. Happens so often that we have here a motivating example for why we want to study binomial random variables. So let's suppose that we're going to select 5 individuals from our college, and we're going to ask them whether they've seen a popular Netflix series. So I haven't heard of any new Netflix series that's, very popular, but you can think of something like Stranger Things or Squid Games. Yeah, let's just pretend it's Squid Games. And then let's suppose that each individual is asked whether they've seen this series or not. Obviously, that's a yes/no response. Now, if Netflix announces that roughly 35% of college age students have seen the series, then that would be these individuals here in the population, that roughly 35% of them have seen this show. So this gives you an idea of how people should respond. If you just pick someone at random and ask them, have you seen Squid Games? They're going to reply with yes or no. Now, according to Netflix, is essentially gives you that the probability of them saying yes, they've seen it, is 0.35. Because there should be 35 individuals for around every 100 individuals that have seen this show. You also get the complement. So the probability of no is 1 minus the probability of a yes, which is 0.65. All right, so just from that statement, we've got these two probabilities. What I'm going to do is I'm going to go ahead and say, I'm only going to pick 5 individuals. So let's note that we're going to go ahead and say, if I take a sample of size little n equals 5, I'm then interested in the number of individuals that are going to say yes. So again, we would pick just 5 individuals. So something like this, maybe. So 5 individuals. Now let's go ahead and describe this random variable x, and this is going to be very common from here on out. We want to go ahead and let x be the number of individuals who are going to say yes in that sample. So if I ask 5 people whether they've seen Netflix or not, then I can observe exactly 0 of them. The random variable could be 0. That means that no one saw the show, right? In other words, no one says yes, they've seen the show. 1 person could observe the show. 2 people could observe the show. 3 people, 4, or 5. So if I'm tracking the number of successes, the potential values of my random variable are always going to be from 0 all the way up to the sample size, because then the whole group could, respond with yes. Okay, so we're almost done there. We've got our possible values. Now let's go ahead and find the probability. And this is where it gets a little bit hard. So we're only going to do it for 1 or 2 of these. So if your random variable is 0 for the sample of size 5, then that means that, so in other words, the probability that my random variable, the number of people who respond with yes, is 0, that means that all of them respond with no. And this is a probability that we can find. So this is equal to the probability that the first individual says no, and the second individual says no, and the third individual says no. And obviously, you can see that it'll be the fourth says no, as well as the fifth person is going to say no. So we saw this because of the and nature. That is the multiplication rule. So this would be the probability that the first one says no times the probability that the second one says no. And we'll just keep going until we get to the very last one, the probability that the fifth one says no. And here's something pretty interesting. Because I'm taking a sample, and we already know that the samples have to be random, we're going to go ahead and say, because there's a random sample of people, the individuals selected are independent. So that means that it doesn't matter who was selected first or second, the probabilities are the same. And so we saw that previously, that independence basically says that the order doesn't matter because this conditional statement wouldn't matter, right? The second no, given that the first one was no. So this is just probability of no times probability of no times probability of no. And we can compute that pretty easily because that's just simply probability of no to the fifth power. So we throw that into a calculator, that's probability of no, that was 0.65 raised to the 5. So if we throw that into a calculator, that's 0.116029. All right, so check that out. We've got our first probability. And now we need to go ahead and find all of the other probabilities. You can actually find this one as well, because this one right here will be the probability of yes for all 5 of them. So that'll be probability that x, my random variable is 5. So that's 0.35 raised to the 5th power. I think that gives you 0.00525. All right, now I just want to talk about one of them. So let's maybe talk about the probability that the random variable x is 1. And if you're feeling a little overwhelmed right now, that's normal. Just follow along for the video, and you'll see that the way that we're going to do things in this class is actually very easy. So this problem, yes, it does. I say is very common, but you will not have to do it like this. Okay, so let's go ahead and just analyze what is the probability that the random variable could be 1. And this is where it gets tricky, because you're saying one response from one of these 5 individuals was yes, all others were no. So you actually need to consider every potential way that this could occur. And so the way that this could occur is the first person can say yes, the second says no, now third one says no, fourth one says no, fifth one says no. Then the other way that this could occur is the second person says yes. So the first one said no, and then all of the other ones are no. So the y is just going to travel downward. And so these are all of the different ways that we can observe one success in this group of 5 individuals. And so you actually would need to do this. So it's actually pretty easy, because if you follow the same logic, there was 1, 2, 3, 4, 5. So there's 5 different ways that this could occur, multiplied by the corresponding probability. So every probability is actually going to be the same. The probability of a yes is 0.35. So that's a yes. There's only one of those. You guys can see it here. And then there's 0.65, and there are 4 of them. And if you throw this into a calculator, you will get the correct probability that goes in here. All right, so that was pretty easy. Hopefully you can see why this would be difficult when X is 2, because then you got to consider every potential way that 2 individuals can say yes when you ask just 5 of them. So it turns out that there's a very famous formula for this that you might have seen in algebra. If you didn't, it's okay. And it's known as the binomial coefficient formula. And here is the formula that people used to use to compute this. So this basically tells you how many ways, so in a sample size 5, how many yeses are there? And so this just counts the number of possible outcomes when you observe just X. So in other words, how many ways can one person say 1? Here is one of them. Here's another, 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 and another. So it turns out that that's given by this combination formula. And if you've seen it, awesome. If not, don't worry too much about it, because then you see that immediately right after that number that counts the number of ways that that random variable can occur, you see that you have the probability of success 0.035 raised to the number of times of success. So this is the number of times of success X, and therefore we're raising P to that power. So this formula can always be used. So you can do all of this stuff by hand, but we're not going to use it. We're going to use an easier method here. And what we're going to do is we're going to use StatCrunch for this. So if we, oh, we got to sign in. Give me a sec. All right, signed in now. So in StatCrunch, what we're doing here is we're actually considering something called a binomial random variable, which is going to be X is the number of people that say yes when you ask a group of certain size. And we can get all that information by simply going to stats, calculator, binomial. So if you click on binomial, you get this applet pop up. And the applet is amazing because it essentially says, tell me the sample size that you're considering. So in our case, it was 5. And tell me the probability of success. So that's 0.35. If I press enter, you get a nice distribution. So here we see the distribution as a graph, not as a table. But if I mess with this, change the equality to, for example, 0 and press enter, look at that number, 0.01160. 0.0116029. So this is what I did by hand, and you can see how StatCrunch did it, but just much easily because it's using that formula. So that's what the little applet here does. If you know N and P, it just uses the formula. You see the number of successes, possible values for a random variable at the bottom down here. Can't annotate right now for some reason. Okay, that's weird. Anyway, but here we have it on the 0, 1, on the x-axis, 2, 3, 4, 5. And you can see that the most likely outcome is 2. So if I find the probability that X is 2, there are 2 successes, that's 0.03364. So I know what goes in here now. 0.2, was it 0? Oh, wow, I completely messed that up. 0.3364. So that's the most likely outcome. So 5 individuals will respond with a yes. All right. So notice how easy that was. All I need is the sample size and the probability of success. And StatCrunch will tell you everything that you want to know about this random variable by using the calculator function. Now, there is one drawback to this, and it's that you got to make sure that you do get this binomial experiment. So the only drawback is that you do need to check that you have what's called as a binomial experiment. And the reason why this is very common, is that I'm going to essentially say a binomial experiment. You always just go through this checklist: condition 1, condition 2, condition 3, and condition 4. And basically, it means that you're going to do an experiment. In this case, the experiment is going to be analyzing the individual selected a fixed number of times. So you need to determine this ahead of time. How many individuals are you going to ask? And here, the trials are very easy because it's basically just simply our sample. It's going to be our sample size. So if you pick, let's say, 4 rocks at random, and you're going to analyze whether you find some kind of like mineral deposit on that rock, then your sample size is 4. You're looking for mineral deposits 4 times. So condition 1 wouldn't be met. Condition 2, are the trials independent? So whatever happens on the first trial should not influence what happens on the next trial. Part of that reason is you want these probabilities to remain the same each time. Okay, so that one we're going to go ahead and almost always will be given. It's going to be assumed whenever you take a simple random sample. So we're going to assume that that's true given a simple random sample. All right, condition 3 is that each trial needs to have 2 outcomes. And I mean mutually exclusive, which means it's either a yes or a no. It's either a success or a failure. And the success would be yes, the failure would be a no. And that's essentially what we had in our trial above, right? Have you seen this movie? Yes or no, yes or no, or the series. And the last one is a little bit complicated, but says the probability of success needs to remain the same for each trial. And so in other words, the probability of observing something, if they go first or if they go fifth, really should not be changing. And so condition 2 and 4 are somewhat tied together. All right, and that's pretty much it. So again, if we have a binomial experiment and you're interested in describing the random variable, which is the number of successes during that binomial experiment, then the random variable x is called binomial random variable. And you saw how easy it was to analyze. So we basically just literally did 3 clicks in StatCrunch, and we got everything that we potentially wanted to know about that random variable. All right, so in the next video, we'll go ahead and demonstrate how to determine whether something is binomial or not. All right, thank you for joining me.